So today we're going to continue graphing your favorites, I've found out. And we're going to just kind of say some general ways that we really always want to graph. So we need to always find the x and the y-intercepts. We're going to graph all the asymptotes. And horizontal asymptotes, now we're going to have three different things that could happen. So m and n are the degrees of p of x and q of x going on right here. So we have the two polynomials still for this rational function. So if the degree is bigger or smaller on the numerator or the same, it's going to see three different things that could happen. So if the degree of the numerator is bigger than the degree of the denominator, if the degree of the numerator is smaller than the degree of the denominator, or if they are the same. So let's see, it says the degrees m is the degree of the numerator, and n is the degree of the denominator. So here, if m is smaller, so that numerator is smaller, then you're going to have the line y equals 0 as your horizontal asymptote. If the degrees are exactly the same going on here, then you're going to have this line a sub n over b sub n as a horizontal asymptote. So what that means, for example, if I had 2x squared plus 5 over 5x squared minus x, something like this. So here I have a degree of 2 in the numerator and a degree of 2 in the denominator as my polynomial degrees. So what I'm going to do is I'm going to take the leading coefficient divided by the leading coefficient, and I'm going to have y equals 2/5 as my horizontal asymptote. When the numerator is bigger, when that degree is bigger in the numerator, then you won't have any horizontal asymptote. So that's really important to have down those three steps for finding your horizontal asymptote. So again, in general, we're going to find the x-intercept, and we do that by putting y equals to 0 and always writing it as a point, okay? To find the y-intercept, we're going to set x equal to 0, and again, we'll write as a point. Then we're going to find all the horizontal asymptotes, and so far we've learned how to find vertical asymptotes and horizontal asymptotes. And just a quick review, vertical asymptotes are where the denominator equals 0. And then any more points, and when you fill in those points, I always pick points around the vertical asymptote. It usually will help you out a little bit, and make a graph. After you get the graph, you can state the domain and range. Alright, so let's look at this first one. We're going to do all of that we just talked about and make the graph. So let's first find the x-intercept. To do that, I set y equal to 0. So anywhere I see a y, I'm going to plug in 0 for y. So 0 equals 6 divided by x squared plus 1. Well, I really don't care about the denominator. I'm just looking to see where the numerator would equal 0, because that's what would 0 over anything would give me 0. And this could never happen. So there are no x-intercepts. Let's go find our y-intercept. That's where I set x equal to 0. So anywhere I see an x, I'm going to plug in 0. And I got out 6. So I have a y-intercept of 0, 6. Okay, so let's figure out what is our horizontal asymptote. Is the numerator bigger, smaller, or the same? So the numerator is smaller than the denominator degree. So I have a horizontal asymptote at y equals 0. pretend that that actually did get the 0 down there. Okay. And vertical asymptotes are where the denominator equals 0. And here I can see a square, x squared could never equal -1, so there are none. Okay, so the last thing I'm going to do is try to find some points. And since I don't have a vertical asymptote, I'm going to go ahead and just find them around that point I already found of 0, 6. So you can pick which ones you like. Put this in the calculator and see. So for instance, at -2, I was around 1.2. -1, 3. We already found 0, 6. So at -2, 1.2, at -1. So now I approach those asymptotes for the horizontal, but I never actually touch it. Okay, let's look at this guy. Let's find the x-intercept first. So I plug 0 in for y, and again, I only need to look at the numerator. And here I see that x would be 0. Find our y-intercept. And I got out that same point, 0, 0. Let's find some vertical asymptotes. So I'm going to factor this one, and I got plus or minus 3. And then for my horizontal asymptote, I see that they have the same degree. So I'm going to take those leading coefficients, make sure it is an equation, y equals still 2 over 1, so I would just have y equals 2. Okay, so now I can go get some points. I'm going to find them around both -3 and 3. Actually, this was at plus or minus. If you look in your table, you're going to get both of those to be plus or minus. So at +4 and -4, I get out the same amount. Four, and there you go. What a beautiful graph. use the quadratic formula. And I found two x-intercepts. Finding the y-intercept. I got out of 2. Okay, let's find the vertical asymptote. X equals 2. And let's find the horizontal asymptote. So let's look at that degree. It is the numerator has a larger degree. So there are no horizontal asymptotes. Okay, if you look at this though, you're going to see something else, and we haven't talked about it. This is called a slant asymptote. Hopefully, if you haven't already, you are putting this in your graphing calculator so you can see what that is looking like. So a slant asymptote could be any kind of linear asymptote, and this is going to happen when the degree of the numerator is bigger than the denominator by 1. Okay? So when that degree is only bigger by 1. So I'm looking and I see, well, this degree is 2 and this degree is 1. So yes, 2 is bigger by 1. When this happens, you're going to divide. So I'm going to take x minus 2, divide it into x squared plus 3x minus 4. So I take my x times 2 and got x squared, x times x to be x squared, x times negative 2, negative 2x squared. Now I'm going to subtract that. Now I need a positive 5. And I'm going to subtract that. So this is the thing. Your slant asymptote is this part right here. You do not ever have to worry about the remainder, whether it's 0 or 5 or whatever. You never have to worry about it. So my slant asymptote in this case is y equals x plus 5. Do not forget the y equals. This is still an equation of a line. So let's see, I have a y-intercept of 5. And then I'm going to go with the slope of 1. So up 1 over 1, up 1 over 1, or down 1, back 1. So now I can see my slant asymptote. So I've got this part of the graph, but I'm missing another part. So I need to get some more points. Well, the farther out negative I go, I'm going to be approaching this asymptote the whole time. And in between this asymptote and this asymptote, you're going to get all these values that we've already graphed. So now I need to go on the right side of the asymptote for x equals 2. So let's pick some values there. And they end up being up here. I'm a little bit off, sorry. Get those from your graphing calculator. And it makes it look like this. And again, the bigger you go out this way, the more you're just going to approach that asymptote. So I'm going to let you try these next few on your own. Please fill them in so that you can come and check with your group to see how you do. And if you have any questions, I'll be more than ready to help you. Other than that, have a good night.